Hello everyone, I'm Rakhi. Me and Divyanshu sir will be taking your chemistry class throughout the year, online or offline. Today we'll be discussing the first chapter of our syllabus, that is chemical reactions and equations. But before I start doing this chapter with you guys, let me just explain you a few rules of my class. First important thing, when you are in the class, right now the classes are going online, later on it will be offline. You're not supposed to talk at all. So it should be pin drop silence in the class. Whatever has been taught or whatever I'm teaching, very nicely and neatly the note should be written. Second important thing, you have to revise whatever has been taught in the last class for the next class, because I'll be asking questions on the basis of that. And third thing is, after the chapter or after a particular topic, when you'll be given some assignment, that assignment has to be submitted on time. If the assignment is not submitted on time, in that case, I do not allow people to attend my class any further. Okay, this is not now. This has been there from many years. So these are few fixed rules. Apart from that, you can ask me n number of doubts. You can ask me anything multiple times, and I'll be available to explain over the phone, on the WhatsApp, or or face to face when this lockdown will get over. Okay, so now we'll start chemical reactions and equations. So now we will discuss in detail the terms chemical reactions and equations. So when I have to understand what is chemical reaction, we need to understand the basic terminology or basic science behind the chemical reaction also. We should know the literal meaning of the chemical reaction also. So chemical reactions are certain events which is happening all around us every single time, all the moment, irrespective of we are able to feel them or able to judge them or able to identify them or not. So chemical reactions are something which are happening all around us. So when I mention it's happening all around us, there are few examples which I can tell you and you can observe and you can relate. And that is like cooking of food, curdling of curd, uh, when we are respiring and respiration inside our body is happening, when we are eating food, digestion is happening, plants are doing photosynthesis, and ripening of fruits, rusting of iron. All these different events, what we had seen in our life, or all these activities, what we had seen in our life, which we encounter every day, are nothing else but the chemical reactions. So, what exactly are chemical reactions? Chemical reactions, if I talk in the bookish term, chemical reaction is nothing else but formation of new substance from the older substances. Whatever the older substances are, there are some changes happen in those older substances and they got converted into new substances altogether. And those new substances have the new properties now. For example, if I have taken a potato, I have taken a tomato, and I have just kept it separately. Okay. And I have kept it separately. If I'll eat the tomato raw, if I'll eat the potato raw, it will have a different taste. Now, what I have done is I have cut them into small, small pieces, and now I have cooked them on the flame with some ingredients and all that. And then eventually, what happened? Even if I would not have added anything to it and would have just put it on the flame to heat it, what would have happened? The potato and tomato, whatever the substances are present inside the potato and tomato, that would have converted into something else. And now the taste of the same potato when it was raw would be different than the ones it is cooked. Okay, or the same tomato would taste differently. That means what has happened? The properties have changed, the appearance has changed. So that is what exactly the chemical reaction means. Same thing happens when you curdle the milk. Milk is liquid in nature, milk is bland in taste, curd is sour in taste, curd is semi-solid in nature. When you talk about iron, iron is a very strong element. It's very hard element, but when it becomes rust, it becomes powdery, dusty stuff, which can be broken if you apply little pressure also. So basically, what is happening when any chemical reaction is happening? The substances which are present in a particular material to what we are observing, those substances are converting into new substances altogether, and the properties are changing. But how the changes happen in the substances, how the older substances become new substances, how the chemical properties change, how the new substances are become completely different, their properties are different from the older substances. What is the reason behind it? So understand, do not go only by the chemical reaction definition in the book, which is new substances are formed and the new properties are exhibited when the chemical reaction happens. So what exactly happens in the chemical reaction is that whatever the substances you have, they have some chemical bonds within them. What are chemical bonds? We have studied in grade 9 that there are atoms and molecules, and those atoms individually elements have all same type of atoms. When we talk about compounds, compounds have different kind of atoms combined together through the chemical bond. And what is that chemical bond made up of, or how that chemical bonds form? The chemical bonds form by either exchange of electrons or by sharing the electrons. Such kind of bonds are called ionic bonds or covalent bonds. See, when we talk about an atom, when we talk about an atom, that's how our atom looks like. Okay, obviously it doesn't look like this. I'm just giving you a slight idea. Okay, this is a very rough diagram. That's not how exactly your atom looks like. So 1 2 3 4 5 6 7. Okay, so this is my atom. Okay, so when I talk about atom, the identity of atom is due to its nucleus. When we talk about atomic number, if you remember, we had done it in grade 9. Atomic number is equal to number of protons. Though in a neutral atom, number of protons and electrons are also same, right? But that doesn't mean that the number of electrons can never change. So that is why when I talk about an atom is majorly identified by its nucleus. Electrons can change in an atom. If the electron change happens, that means, and from an atom, let's say I have atom A, I can take out an electron, I can pull out an electron, and then electron will become positively charged and it will be called a positive ion. If I add an electron to another element or other atom, let's say B, it will gain a negative charge and it will be called a negative ion. Are you getting this? So there are when we are bringing the electrons out of their houses, or when we are adding electrons into the atom, the configuration of atom changes, number of electrons change, and hence the atoms now are no more atoms but they are ions. Okay, but element still remains same. Element doesn't change. Why? Because element is due to its nucleus. Whatever the number of protons are present, we are not going to change it. There is nothing which can change the number of protons and neutrons in the atom. Unless that is changed, your atom will not change. Okay, and due to this exchange of electrons or losing electrons or gaining electrons or sharing electrons, the chemical bonds form. So what happens when the chemical reaction takes place? I had, let's say, A, B. This was one molecule, molecule 1, molecule 1, and I had C and D, that is molecule 2. Okay, when the chemical reaction will happen, there are three things which are possible. One is older bonds break. Bonds break. Okay, new bonds form. Or this is called first activity, this is called second. So basically older bonds break or new bonds form, or 1 and 2 both happens. That means older bonds are breaking and new bonds are forming. Both are happening. So any of this happens if in the substances present in anything which we are observing. That means chemical reaction is happening. So let's say when I talk about AB reacting with CD, let's assume these are the products forming A, C, B, D. Now, if you look at this reaction carefully, what has happened? Earlier, the bond was between A and B. Okay, and now the new product is A and C. So what would have happened? There would be a bond breakage between A and B, and a new bond has formed between A and C. That means C has broken its older bond with D. Now A has formed a new bond with C and B has formed a new bond with D. That's how A and C and B and D are formed. A and B was a different molecule altogether. This was molecule 1, this was molecule 2. Now A and C is the third type of molecule, that is molecule 3, and this is molecule 4. Now the interesting point is that all these 4 molecules have all different properties. The properties are not matching at all. So what we have seen? We have seen the older bonds broke, then new bonds formed, and then the whole reaction got completed. This is basically the third case, which I told that first and second both are happening. So let's see more examples of this phenomena where older bonds break, new bonds form. So now, for example, I have A and B, two different substances. Now they have come closer to each other in a particular environment which is favorable for them to make a new bond. A and B will make a new bond. So what has happened over here? The second activity, new bonds formed. Now A was a different entity altogether, B was a different entity altogether. They are not mixed with each other. They have made a bond over here. Now that bond can be an ionic bond or can be a covalent bond depending upon what kind of species this A and B is. If this is a metal and a non-metal, if this is a combination of metal and non-metal, then bond will be most probably an ionic bond. If both are metal, then the reactions generally don't happen. If both are non-metals, in that case, the reaction would be covalent. So all these conditions you would have studied in grade 9. This is just a quick revision of what we have learned in grade 9. So what is exactly chemical reactions? So what is chemical reaction? Chemical reaction is a process in which the substances what we have, they break their existing bonds, they form the new bonds and create the new substances, and those substances will have new properties. The properties will not be matching with the older substances. Okay, so that conversion of older substances into new substances, changing the properties of older substances in new substances properties is due to this. In the molecular level, if you'll check, it is not just because they are simply converting into one to another. The conversion is happening due to the existing bond breakage and new bond formation. But here you have to keep one thing in your mind, and that is very important. That is, when you are reacting, okay, let me take this example itself. So let's say this A is a metal, assume, and this B is a non-metal. Okay, now when this A and B are reacting to each other, they are forming AB molecule, right? So obviously this molecule has a different property than A and B, but has this A become something else? No. Assume this was sodium. Okay, and assume that the non-metal was chlorine. You must have seen this example in grade 11. So this is Na and this is chlorine. They are two reacting with each other, assume. And then what's happening? The resultant molecule which has formed is NaCl. Okay, now when this NaCl has formed, just see, A was NaCl and eventually the molecule which has formed also contains Na. Similarly, B was chlorine and eventually the molecule which formed was also the molecule which formed also contains Cl. That means atoms don't change. Atoms do not convert into something else. Sodium will not convert into magnesium, or chlorine will not convert into fluorine or anything else. Atoms will still remain same. Only their bonding will change. Only the way how they bond with the other substance will change. But their bonding patterns change. Elements do not change in a chemical reactions. The initial composition will still remain the same. Initial elements what started the reaction will still remain same after the product formation or after the reaction is done. Whatever the new substance we have got, that will have same set of elements present in them. So this is very, very important thing which you need to understand. Okay, so now we will understand the basic parts of chemical reaction. Your chemical reaction is made up of different parts. So let me take one basic skeleton of your chemical reaction. This is, let's say, a generic reaction. Generic reaction. Generic reaction means just a general reaction where I'm not specifying what is metal, what is non-metal, what is A, what is B. This is just a basic structure of a reaction. Okay, so now what we can see is A and B are the initial things what we had taken. They have reacted together, they have formed a new bond, and then they have become A and B. So the things which had been taken initially for the reaction, such substances are called as reactants. And after the chemical change has happened, chemical change has happened means when the new bonds have formed and the older bonds have been broken and the new substance has formed, that new substance is called as product. There can be one product, there can be multiple products formed after the reaction. So eventually what is written on the right hand side is always the representation of products, and left hand side is always the representation of your reactants. So reactants are the ones which will initiate the reaction by breaking the older bonds and forming the new bonds, and what you get in result is the products. Okay, this whole way of representing a reaction is called as chemical equation. Now let me tell you the difference between chemical reaction and equation. So chemical reaction is something which is actually happening. That means which is occurring, which is happening, that event of breaking the bond, forming the new bond, and then forming a new compounds and forming the new products is called chemical reaction, which can be an observable reaction or which can be a non-observable reaction, but that is happening. That's an event. Okay, but when you represent that event into your words or when you represent it on the paper, that is called chemical equation. So chemical reaction is the actual event which is happening, and representation of it on the paper is called your chemical equation. Okay, chemical equation can be of two types. Chemical equation can be written in word representation, and second type of way of representing the chemical reaction, chemical equation, is symbolic representation. We will discuss about all this in a while, but now first we will quickly list down what all different chemical reactions we can observe in the nature, or what all different examples we have for chemical reaction, and then we'll go in detail about the chemical equation and chemical reaction. So there are multiple chemical reactions which we can observe, that is respiration in plants and animals, then cooking of food, curdling of milk, burning of fuel, rusting of iron. So these are different chemical reactions. There are many more which you can observe and you can list down. So these are few reactions which you can observe happening all around. There are digestion is also a chemical reaction, respiration is also a chemical reaction. So there are millions of reactions happening all around. So there is one thing where students generally get confused. When they see the changes happening all around them, they are not able to figure out whether the change is a chemical change or another kind of change which is called as a physical change. So what is physical change? Physical change is the change in the state of matter, or physical change means change in the appearance of something just due to few small changes which you have applied physically. So if you have changed the temperature of something, or if you have applied pressure on something, the change which you will see and observe in any substance will be called as physical change. For example, if I talk about ice, so first I'll write down physical change. Physical change is the change. Note this down first, because the definition of physical change is important, because you get a question in Cbse, which of the following are the chemical changes and which of the following are physical changes. So first, before we discuss about the physical change, write down the definition of physical change. Physical change is change in appearance of substance or change in states of matter due to change in temperature, pressure, etc. That is what I have explained just now. So that means there can be change in the appearance, there can be change in state, because we have changed the temperature of the substance, or because we have applied a little amount of pressure on it, or many other things which we can do physically. But the chemical composition of that molecule will not change, or that substance will not change. That means no bonds will break at all. No new bonds will form, no older bonds will break. This is something called as physical change. For example, if I talk about boiling of water. So when we talk about water, water is nothing else but H2O. All of us know about it. Now when water is in the liquid form, then also it is H2O. When you have applied heat to it and now it has become steam, then also it is H2O. But now it is called steam. Its appearance is different. Its states of matter is different. Earlier it was liquid, now it is gaseous. But the molecules inside the steam are still same, and that is water molecules. If you If you decrease the temperature, if you solidify it, it will become ice, it will become solid. So state has got changed. But do the molecules got changed? No, molecules are still water molecules only. Any such kind of change in the substance is called a physical change. For example, if I take a tomato, assume if I take a raw tomato, if I take a raw tomato and I apply a pressure on it, it'll get squeezed, it may burst, enough fluid comes out, right, oozes out. But even if I have applied pressure, will the taste of tomato will change? Will that tomato will become potato after me squeezing it? No. So the composition of the substance still remains the same if you apply any physical change or pressure or temperature on the substance. That kind of changes in any substance is called as physical changes. So now I'll list down some examples where it's mix of chemical changes and physical changes. Try it out on your own and mark them, which one are physical changes and which one are chemical changes, and then I'll discuss and explain it to you. So now you know what is chemical reaction and what is physical change. Chemical reaction is nothing else but chemical change. So what is chemical change, what is physical change? List of the activities have been mentioned here. And now you will mark which one are chemical changes and which one are physical changes. This is a very important question generally asked in the CBSE board exam. Okay, do it on your own. So now, first example is cutting paper into the pieces. So paper is a substance, okay, made up of, let's say, cellulose or whatever, some chemical composition. If I'll cut it into pieces, will paper become a notebook? No. Will a paper become a plant? No. Will it become tree bark? No. So no change in the chemical formula of the paper is happening no matter whatever size you cut it into. So this is a physical change. Physical change I'm mentioning with PC. Okay, burning of wood. Wood is burnt, and now it is, after burning, it is left with some. We are left with some ashes, and a lot of smoke and everything has gone out. So basically, you're left with ashes, smoke, and some water vapors are also released. So wood has now converted into ashes, carbon dioxide and water. This is all what has got released after the burning of wood event has taken place. So your wood is no more wood. It has become ashes. So this is your chemical change. Chemical change I am mentioning with CC. Pickling of mango. Pickling of mango, you have kept it for a longer time, the ingredients have been mixed together, and they'll slowly react. Mango is no more mango. The taste of the mango has changed. It has reacted with the other substances, and the change has taken place, and this is also a chemical change. Melting of wax, that means it was solid and now it has started melting off. That means you have just applied the temperature, you have applied the heat, and earlier it was solid and now it is liquid. Only state change has happened. No chemical composition change has happened. Hence, this will be your physical change. Breaking of glass, again, no change in composition, physical change. Cutting off lemon, no change in composition, physical change. Dissolving sugar into water, no change in the composition. Sugar is still sugar in the water, and water molecules are still present in the water molecule. So it has not converted into a new substance altogether. This is also physical change. Now an important thing, burning of the candle. This is also an example given in multiple books, and there are different answers for this particular example. So burning of candle. So let's see, let me just draw a candle over here. So I have a really bad drawing. And this is my candle, okay. So you will see after some time when the burning of the candle is happening, after some time on the border of your candle, you will see the molten wax spreading through and coming down and dripping off. So what we can see is the wax which is used to make candle, that has started melting off. So that is nothing else but physical change, because melting is not changing the property of your wax, but the thread which is present inside your candle, that thread which is made up of fibers, is burning and converting into different compounds. It is converting into carbon dioxide, some unburnt particles, and water vapor. So that is the reaction happening inside. So half part, or you can say melting of the wax, is nothing else but the physical change, but burning of the wick or burning of the fiber which is inside your candle, that is a chemical change. So they ask you this question, and when they ask you, you have to explain that both changes are happening in the burning of the candle. Melting of wax is a physical change, whereas burning of the thread or the fiber inside is chemical change. So till now, we have understood what is chemical reaction. We have understood what is chemical change, what is physical change. We have seen some examples of chemical change as well as physical change. And we have got a small idea of the representation of chemical reaction on paper, and that is called as chemical equation. Though I started chemical equation in between, and then I left, and then I came on the, then I jumped on the physical change. So now we'll do the chemical equation in much more detail. So as I mentioned, chemical equation is nothing else but the way of representing the event chemical reaction happening. So chemical reaction is an event, whereas representation of that event on paper is called as chemical equation. There are two ways you can represent the chemical reaction on paper. One is by word equation, and second is by symbolic representation. Word equation is what? Word equation is like a storytelling. The way how I say that, okay, carbon reacted with oxygen and formed carbon dioxide gas. Exactly this way, if you are writing it on the paper, this is the word equation of your reaction. Whereas if you write the symbols of the molecules or atoms reacting, symbols like carbon represented by C, oxygen is represented by O2, and then the reaction is taking place, and then it is becoming carbon dioxide in the presence of heat. Carbon dioxide is mentioned as CO2. That way of representation is called as symbolic representation. So let's see some examples. If I have, let's say example 1. Let's say I have taken magnesium ribbon is burnt in the presence of oxygen, in the presence of oxygen, and formed a white powdery substance, magnesium oxide. So I have written basically the whole story of a reaction, that we had taken a magnesium ribbon, burnt it in the presence of oxygen, and then we had formed a white powdery substance, and that is magnesium oxide. It is way too long to write, but it gives you the complete explanation of the reaction. So this is your word representation. Now, if I have to write it in the symbolic representation, how will I write? Magnesium ribbon, that is solid. So I'll write magnesium ribbon with the symbol Mg. Mg is a symbol of magnesium, and ribbon is in the form of solid. Whatever the state of your species is, which is reacting, or the reactant is, you have to mention it. Without mentioning it, your reaction will not be considered valid. Okay, so magnesium, and in the brackets we have mentioned S means solid, that is state of your magnesium, reacted with oxygen or burnt in the presence of oxygen. Oxygen is a gas. Burnt means you have applied heat, so I have mentioned heat over here. Heat is represented by a triangle symbol, and then it formed MgO, that is also solid, magnesium oxide, white powder. So this is how you write a reaction in the symbolic representation. Whenever you are writing a symbolic representation, it is mandatory to mention the states of the reactants as well as products and the other conditions which you have provided for this reaction to happen. It can be temperature, it can be pressure, it can be anything else. So or it can be a catalyst, it can be anything. So whatever is the condition along with the reactants and products, you have to mention it in the reaction representation. So this I will write it as magnesium. This will be written as oxygen. So if you look at my equation, this is how exactly chemical equation has to be written. So this is your symbolic representation. And the important things which you have to keep in mind while you are representing your chemical reaction by symbolic representation, it is mandatory to write symbols of reactants and products. That is the basis of your symbolic representation. Second important thing, states of reactants and products must be mandatorily must be mentioned. Other supporting other supporting environmental conditions must be mentioned. What do you mean by other supporting environmental conditions must be mentioned? If it requires heat or pressure or catalyst, it must be mentioned in the symbolic representation. Next, if heat is getting released, or any energy or or energy in any form is getting released, it needs to be mentioned. For example, here there is energy we have applied heat, and then it has become MgO. But if I talk about burning a piece of paper, in that case, what will happen? The paper piece will burn. Or if I let's not talk about the burning of piece of paper. Let's take any fuel. If I have spoken about butane burning or petrol burning, so if I'm burning a petrol or any fuel or LPG or whatsoever, if I'll burn it, eventually the reactants will get converted into some specific products. Products will be majorly carbon dioxide and water, and a large amount of heat and light will be produced. So apart from the products, there is other energies which are also getting released after the reaction. So that also needs to be mentioned in your symbolic representation. So either if heat is getting released or any other energy is getting released, you have to mention it in the symbolic representation. And those energies can be sound energy, light energy, or heat energy, or any of such energy is getting released, you have to mention it in the symbolic representation. Your symbolic representation of a reaction is incomplete if either of this is missing. So this is very, very important point. Please keep a note of it, because when you will write the reactions in your exam or in your school tests, they'll cut the marks for not mentioning all these things while representing a reaction. Okay. So next we'll talk about what all different characteristics of chemical reactions are, and what all different changes which you can see when a chemical reaction occurs. Okay. So after knowing about chemical reactions and the way of representing of chemical reactions, now we are discussing the characteristics of chemical reaction. What do we mean by characteristics? What all is observable when we do a chemical reaction? Or what all different changes happen when the chemical reactions takes place? So there are multiple different chemical changes which you can see, which you can observe, or which you can feel. So you may observe multiple different changes when a chemical reaction happens. For example, you may find a gas getting evolved, or you may find the product is in a different state altogether. Initially, you had taken the two substances which were solid in nature, or when the reaction was happening, the initial reactant was solid in nature, and after the reaction, the substance has become gas or liquid. Third kind of change which is observable is change in color. The initial reactant was, let's say, colorless, and after reaction it has become of blue color or green color. Or initially the reactant you had taken was of yellow color, let's say, and the product has become of black color. So there can be any such color change. Or the fourth change is the change in temperature of the environment after the reaction took place. So let's say if I have a wood and I am burning that wood, initially I'll apply a small amount of heat, or I'll lit the wood, and then it'll catch fire. It'll catch fire, and a lot of heat will be all around, heat and light energy. So basically lot of heat energy and light energy is getting released. So in the environment, what is happening? The temperature has got increased. So you may find temperature change after the reaction takes place. It is not necessary that temperature will always increase. Temperature may decrease also. Okay, so we'll talk about those type of reactions also. And the fifth type of reaction is the precipitation reaction, or fifth type of change what you'll observe is the formation of a precipitate. So what is precipitate? Precipitate is a semi-solid sort of substance which floats on the top of the reaction mixture. So well, let's say when two compounds have reacted together, they may cause the formation of a semi-solid substance which is floating on the surface, and rest of the thing is in the liquid form. So that kind of formation of a solid layer on the top of the reaction mixture, that is called as precipitate, and which is quite observable. Okay, that many a times those solid thick layers have the specific colors also. So these kind of changes are quite observable. You can observe it through your naked eyes or you can feel them, and these help you in identifying whether the chemical reaction is happening or not happening. So I have just mentioned all these 5 points over here. So these are 5 different characteristics of chemical reaction which will help you in observing whether the chemical reaction is happening or not, so not all of the 5 have to happen in one reaction. Either of them can happen in the reaction. First is evolution of gas, second is change in color, third is change in temperature, fourth is change in state, and fifth is formation of precipitate. Now we'll talk about each of this characteristic in detail with the help of some examples. Okay, so first let's talk about evolution of gas. Evolution of gas. Now let me take an example for evolution of gas. Let's say I have taken zinc granules. Zinc granules can be represented by Zn. Zinc granules are nothing else but small pieces of zinc, and it will be in solid form. I'm reacting it with dilute H2SO4. As mentioned, it will be liquid in nature or aqueous in nature. Okay, dilute H2SO4 is nothing else but sulfuric acid. When I have reacted them together, maybe in the presence of small amount of heat or without heat, this will become ZnSO4. This is called as zinc sulfate. This will be again in the form of liquid. Plus, apart from that, hydrogen gas will get released. Hydrogen gas. So in this reaction, what all we have seen, we had taken zinc in the solid form. Then I have reacted it with dilute H2SO4. The product formed is zinc sulfate. This can be with heating or without heating, either way. And the other product which is formed is hydrogen. So here you can observe 2 different kind of changes. First of all, your zinc has reacted with H2SO4 and formed ZnSO4. So zinc based substance has become liquid now. Zinc initially was solid, H2SO4 was liquid. Okay, so zinc particle state has got changed, and now the new compound which has formed is liquid in nature. Okay, initially the state of the reagents or the reactants what we had taken was solid and liquid. Now the products have what all states? Liquid and gas. So change in state. This example can be true for that also. Initially the reagents or the reactants what we had taken were in liquid and the solid state. Products which we are getting are in liquid and the gas. And the first is evolution of gas. That is also the example of this. This is hydrogen which is getting released. How will we observe that the hydrogen is getting released? The effervescence of hydrogen will come out. You'll see the solution getting, you will see the bubbles coming out of the solution. How will we test whether this gas is hydrogen only? They do ask such kind of questions, that how will you test that the gas which is coming out is hydrogen? You will burn a matchstick near the flask or above the flask from where the gas is getting released, and if you hear a pop sound, pat, that kind of sound, that also tells you that the gas which is getting released is nothing else but hydrogen gas. So what we have got to know, if you add zinc into dilute H2SO4, the reaction will take place between them. ZnSO4, a salt, will form, which is called as zinc sulfate, and the hydrogen gas will get released. How to see? Hydrogen gas doesn't have any color, so you won't be able to see it through the naked eyes. You can just feel it, or you can just see the effervescence in your liquid, the bubbles forming in the liquid or the solution of reaction or the reaction mixture. Apart from that, you can just validate this fact by burning a matchstick near your flask. You'll hear a pop sound, and that will also clarify, or that will also ensure that the gas which is getting released is nothing else but the hydrogen gas. So this is one example of evolution of gas. Another example I can give you. Another example is you take magnesium, reacted with HCl. Magnesium is solid, HCl is liquid, dilute HCl, and again the reaction what will take place will be MgCl2, again liquid, plus hydrogen gas will get released. Again the similar kind of reaction. We had taken solid and liquid substances. This is dilute HCl. You can take concentrated HCl also, it will show the same reaction. So magnesium solid in nature, HCl liquid in nature. The product you got is in liquid form, that is MgCl2 magnesium chloride, and you got the hydrogen gas out of it. So both of these reactions are showing two things. One is change in state of the products forming. Second is the gas is getting evolved. So this evolution of gas will generally give you the effervescence in the liquid, and that will help you in identifying whether the gas is getting released or not. Or that will help you in ensuring that the gas is getting released after the reaction is taking place. Okay. Now, next example we'll see is for change in color. So when we are talking about change in color, there are so many examples which we can see around where the color change happens when the chemical reaction takes place. For example, if I talk about rusting of iron, iron is generally, what do you call it, metallic color, grayish color material, and when if you leave it unattended, where there is a moisture and there is air, all that is present over the period of time, it's a very slow reaction. Over a period of time you will find a brown color, reddish brown color flakes coming on the on that iron piece, and that is called rust. So basically iron was initially a grayish color substance, and then after some time it formed, after some time as in after a long time, when the moisture and water acted on it, it had become iron oxide, a specific type of iron oxide, and the color of that iron oxide had become what? Reddish brown. That means change in color. The very similar thing happened with the silver. So silver, if you keep it in open for a longer time, there are some gases which are present in the air, generally hydrogen disulfide, that is H2S, and some sulfur dioxide, sulfur trioxide, and some amount of moisture. So all these basically slowly start reacting with the silver, and that silver turns black. The silver turns black due to the reaction with sulfur. So that is why you see your white, silvery, shiny ornaments or utensils lose their shine. They become dull, and then sometimes they get that black coating on them, which you have to rub off and clean it. And that is nothing else but the chemical change what has happened on the silver. So that silver color changed into black, or metallic color or grayish color converted into reddish brown. All that is color change only. That is what we see all around us. Similarly, your copper substances, the copper mugs and copper glasses, if you keep water in it for longer time, you will see it getting discolored, a different color, a greenish color coating comes on it. You have to clean it very often. Why is it so? Because of the moisture and the gases which are present in the air tends to react with that top layer of the copper, and hence the color change happens, and the chemical composition of that copper also changes. So it is no more copper, it becomes copper based compounds, copper oxides, copper carbonates, because of which that green color forms. Now I'll tell you some more examples over here. So if you take iron piece, iron is grayish color substance, which is solid piece in copper sulfate dilute solution I have taken, and this is of blue color. When you'll do the reaction between them, what will happen? It will form FeSO4, ferrous sulfate, and that will be in the liquid form or aqueous form, but color will change. Initially the solution color was blue, now the solution color will be green, and the copper, brown color copper particles or precipitate, not exactly precipitate, but the copper particles will get generated. Okay, so your grayish color substance of iron has got converted into ferrous sulfate, which is green now. So the visible change would be the blue color solution will become a green color solution. Similarly, if you'll take copper piece, that is reddish brown color thing, and if you'll react it with water, it won't react immediately. It will take its own good time. That's what I said. If you keep it open in the moisture, in the presence of air, it will slowly water particles or moisture particles will react with copper, and the greenish color layer will form. That greenish color layer is nothing else but copper hydroxide. This is called CuOH whole twice is called copper hydroxide. This is, I'm sorry, I've not mentioned the names. This is copper hydroxide. This is your ferrous sulfate. This is your copper sulfate. Right? This is iron. This is copper. This is copper. This is water. This is your copper hydroxide, and this is hydrogen gas. So what we can see here, your reddish brown solid has now become greenish color solid. So basically greenish layer will come over it, and along with this hydrogen gas is getting released. So this reaction is showing us three different things. One is change in color, second is change in state, and third is formation of gas. Similarly, I can take one more example, that is CuCO3, copper carbonate. Copper carbonate. It is of green color solid. If I heat it, it will become copper oxide. Copper oxide, which is a black color solid, and carbon dioxide gas will get released. Again, it is showing you three different changes. One is change in state, second is formation of gas, and third is change in color. Gases, many a times we represent through an up arrow. Up arrow means these are releasing in the environment. So many a times you will find, instead of simply writing G over here, in some of the books it would be mentioned as up arrow. Up arrow or G is basically representing the same thing, that is gaseous state. Okay, so this is about change in color. Now we are left with two different type of changes which we still have to discuss, that is change in temperature and formation of precipitate. Both of these changes in detail we'll discuss in the next class. Apart from this, we will discuss about different type of chemical reactions which can occur, and we'll see how those reactions takes place, what are the changes takes place, and third important thing what we'll discuss in the next class is how to balance a chemical reaction. So today what all we have learned what is chemical reaction, what is chemical change, what is physical change, how to represent a chemical reaction, what that representation is called. That representation is called chemical equation. What all different ways a chemical equation can be written as. One is word equation, second is symbolic representation. Word equation is like a storytelling, how the reaction happened, everything you mention in the word format, whereas symbolic representation is in with the help of symbols of the elements and molecules and compounds. You represent the whole reaction. You mention the states of the products there, states of the reactants over there. You write their names. You write the names of the reactant as well as products. You mention the conditions required for the reaction, that is heat, temperature, pressure, catalyst, and if there is some sort of energy which is getting released after the reaction, that also you mention in that reaction or in that representation. Next, what we have learned what all different changes we can see in a chemical reaction, what all we can observe, so that we get to know that okay, chemical reaction is happening. Five different kind of changes we have spoken about. One is formation of a gas, second is change in color, third is change in state, fourth is change in temperature, and fifth is the formation of precipitate. So all these different changes we can observe in a chemical reaction, and we can identify and tell that a chemical reaction is happening, out of which we have discussed three different characteristics of chemical reaction. One we have discussed the formation of a gas in a chemical reaction. Second, we have discussed the change in state of products from reactants. Basically reactants are of different state and the products forming are of different state. And third, we have spoken about change in color. So this is about today's class. In next class I have told you what all I'll be discussing. Write the notes very properly, revise all that what we have done, and then read through a few pages of your module which I'll share with you, so that it will be easier for you to understand it in the next class.